Hey everyone, how we doing today? Hopefully it's a good one. We're going to go to our packet, page 25, and we're going to do section 2.4, parallel and perpendicular lines. So we are skipping a couple sections. We're going to go back, but I wanted to hit this first because it's really close to what we've been doing lately with slope-intercept form. So parallel and perpendicular lines are very specific types of lines. So we know parallel lines are two lines that never touch, and you should have learned that from middle school. So they're two lines, they're perfectly straight, they never will touch each other. Perpendicular lines are also straight lines, but they do touch each other. They intersect at a 90-degree angle. Okay, so if you have a line that's vertical and a line that's horizontal, like our X and Y axis, like right here, they make a perpendicular line because we know that that is a right angle. So the X and Y axis is an example of perpendicular lines. Okay. All right, so here we go. So parallel lines. So what I want to do is graph. I want you to be able to see how equations will form parallel lines. Okay, so I want you to be able to tell me if two equations are going to create parallel lines, or if they're going to create perpendicular lines, or if they're not going to create either one of those, which means they'll just be intersecting lines where they're crossed somewhere, but not at a perpendicular 90-degree angle. Okay, so here we go. So for parallel lines, we're going to graph these two and see if we can figure out what the relationship is. So I gave you two equations. Let's get them graphed. So we know we're going to graph in y equals mx plus b because it's in slope-intercept form. And I can see that the y-intercept is -6. So I'm going to plot at -6, and then I'm going to rise 3 and run 5. So this should be pretty easy at this point. And then here's my line. So I'm just gonna, I don't know what my ends look like. Let's get a regular line in there so we can see it. Okay, here we go. So I'm gonna graph this line and it looks like this. So there's my first line. So you draw that in. My second line, okay, because I want them to be parallel. So let's check this one out. So we have y equals 3/5 x plus 4. So we know we graph our b first. Okay, so 4, 1, 2, 3, 4. And then we're going to graph again, rise 3, run 5. 1, 2, 3. 1, 2, 3, 4, 5. Okay, let's go ahead and draw that line. So same thing, I'm going to make sure I have the same style line. And there we have it all the way through that graph. Okay, so if you look at those two lines, those lines are perfectly parallel. They're never going to touch. If they continue on and on forever, they will never touch each other. So we see that these two equations have created parallel lines. So take a second and look at those equations. And what do you think made them parallel? So look at the equations. What do you think made them parallel? All right, so you should see, one thing you should see is that, let me highlight it for you. 3/5 and 3/5 are exactly the same. So that means they have the same slope. So if they have the same slope, you're on your way to being perpendicular. So same slopes. Or in other words, they have to have the same m. Okay, but the other thing you need to look at is that the b has to be different. Now, the reason the b will have to be different is because if it was the same, like if they were both -6, it'd be the exact same line. So the b's or the y-intercepts do have to be different. So this one, like you have a graph down at -6, and this one you have a graph up at +4. So they're going to be two different lines because the y-intercept is different. So they have to have the same slope, but they have to have different y-intercepts, or the b. Okay, so I'm going to stop there and we're going to come down and we're going to look at example 1 so that way we can try it. So I want to do all the parallel line stuff first and then we'll come back and do the perpendicular second. All right, I see in this equation my fraction got shifted over a little bit, so it's probably not right on your paper either. So that equation is y equals 3/4 x minus 2. So you might need to write that right below or off to the side. All right, so you might need to write that below or off to the side. So here we go. This is how we're going to solve this equation. It says, what is the equation of the line in slope-intercept form? So remember, I need to write an equation, y equals mx plus b. I need to find an m, I need to find a b in order to complete this question. It says the equation has to pass through the point 8, 9. So you have an x and you have a y, and it has to be parallel. What does parallel mean again? Well, we just said it right up here. They have to have the same slopes. So what is the slope of this equation? Yep, it's 3/4. So that means I have to use the same exact slope in my new equation in order for me to find a slope or an equation that's parallel to this one, okay, that they have. But now remember, I can't use the -2 for b because if I use the -2 again, you'd have the same exact line. We don't want that. We want one that's parallel. So we have to find a new b. The only way that we're going to find a new b is to plug the numbers in to y equals mx plus b and find our b, just like we have been all along. So I have an x, I have a y, and I have my parallel m, which means it's going to be the same. Okay, so if we want to find the new equation, we use the same slope, so we're going to use 3/4. We're going to find the new b. So that means we're going to take y equals mx plus b, and we're going to plug in our y that we want on our graph, 9. We want the m, which we have to have it parallel, so it has to be the same, times x, which is going to be 8, and then plus b. And we're going to solve that just like we did before. So you plug in the y, the m, and the x, and now let's solve. So 3/4 times 8. If you need help with that, use your calculator. I know 3/4 times 8 is 6, plus b equals 9. Now I'm going to go ahead and solve for b by subtracting 6, and I get 3. So my equation is y equals 3/4 x, so that way they have the same slope. So look, 3/4, 3/4, and then this one had a b of -2. This one is going to have a b of +3. So these two lines are going to be parallel to each other because they have the same slope, but they have different b's. And I also know it's going to go right through 8, 9 because I used 8, 9 as my ordered pair. Okay? All right. So I want you to take a second, pause the video, and I want you to try this one on your own. Okay. So it's the same type of question. I want you to do the same thing. So pause it. When you're done, come back and see how you did. Okay, so you should be back and you should have an answer. Let's see how you did. So because I want to go through the point 3, 2, and I want y equals mx plus b, I'm going to type y equals. I know my line has to be parallel. So if I see the slope is 3 right here, I'm going to use a slope of 3 because that's how I get a parallel slope. They have to be the same. So down here I can write 3x, but I don't know the b. And remember, I can't use this one because then it'll be the exact same equation. So we got to plug in x and y. So y is 2 equals m times x plus b. And we're going to solve it. 3 times 3 is 9. And then subtract your 9 to undo. And if I cancel out, I get b equals -7. So b is -7. So there's my equation in slope and intercept form. And it's going to be parallel to this equation. How do I know? Well, because it's got the same slope and it has a different b. How do I know it's going to go through 3, 2? Because I used 3, 2. Here's my x right here, 3, and here's my y, 2. So I know it's going to go through that point because I used it, okay? If you use the point, that line has to go through there, okay? All right. And I can also show you on Desmos. Watch this, 3, 2. So let me see. I think I have my Desmos pulled up. So 3, 2. So I'll show you with your tried example. So the point was 3, 2. So if I go to Desmos, so I'm using one of my Desmos graphing calculators. I need parentheses 3, comma 2. I don't have a comma in here. There's a comma. Okay, so there's 3, comma 2. So look, it plotted my point for me. Okay, down here, I'm going to put in my equation that we had found. So what was the equation that we had found? It was y equals 3x minus 7. And I'll show you that it goes right through that point. y equals 3x minus 7. Okay, so let me get y, I need a lowercase y, equals 3x minus 7. Ooh, look at that. Went right through that point. Okay, you see that on that graph? It went right through this point right here. So we know it's going to go through that point. And if you want me to prove to you that it's parallel, watch this. The other equation was y equals 3x plus 4. So here I go, y equals 3x plus 4. I'm going to pop it in so you can see it. So I need a lowercase y equals 3x minus 4. Bam, look at that, guys. Parallel. So that blue line is parallel to the green line, and it went through that point. So that's how you do it. Looks cool, huh? All right, let's go on back up to perpendicular lines. All right, so let's get back to graphing. So in order for us to see these perpendicular lines, let's graph these two equations. So we're going to go down to -6, and then we're going to rise 3 and run 5 for our slope. Okay, so I'm going to graph this line. Oh, didn't use my line tool. What's up with that, Miss Sakura? Oh, I know why, because I have to click on that. There we go. Okay, here we go, right there. Okay, so there's our first line. Okay, the second line, let's go ahead and graph. All right, here we go. So it's y equals -5x, or -5/3 x plus 4. So we're going to go up to 4. And this time we're going to go down 5 over 3. And then I'm going to grab my line tool again. And yep, looks good. And I'm going to go ahead and graph that line. All right. That looks good. Okay, so are these perpendicular? Well, they are perpendicular. And the reason that I know that they're perpendicular is because I said they are. No, just joking. If you tilt your head to the side a little bit, they do look like a straight, like if you tilt your head to the side, it looks like a straight across line. So look at it. So it's straight across the bottom line, this one. And then if you look at it, this one's going straight up from it. So those are perpendicular lines. Okay, they're going to form a 90-degree angle right here. Oh, I'm sorry. I didn't mean to change that. Look, I'm all crazy now. Okay. Right here is going to be a 90-degree angle. I'm going to make it yellow. Okay, so there's my 90-degree angle. So they are perpendicular lines, okay? So how do I know, looking back at those equations, how do I know those two lines are perpendicular? For sure, because this is a rule in math. All right, so if I'm looking at it, my slopes are actually kind of similar, aren't they? This one is 3/5, and this one is 5/3. It's flipped around, isn't it? All right, and look at this one is positive and this one is negative. So you have to flip it and you have to make it opposite. So you're going to flip it and make it opposite. So that's what makes parallel lines. Or sorry, not parallel, perpendicular. That's what makes perpendicular lines. You have to have the slope, and I don't want to use blue. The slopes have to be opposite because one has to be positive and one has to be negative. Like the first one was positive, the second one was a negative slope. So the slopes are opposite. So one positive, one negative. I'll write that right underneath. Reciprocals. That's what it means to flip it. We talked about this before. It's been a little bit though. And right underneath, I'm going to write flip. Okay, because we flip it. 3/5 flips to 5/3. And that's how you get perpendicular lines. If you have opposite reciprocals, then for the slope, then you have perpendicular lines automatically. Okay, this is a geometry thing as well. So next year you'll be talking more about this in geometry. So you need to learn a little bit about it now. So far we are good to go. We have parallel lines have same slopes, but they have to have a different B. These ones have to have opposite reciprocal slopes. The B can be the same or it can be different. It doesn't really matter. Okay, so that's what we know we have to have at this point. So I'm going to come down here and I'm going to look at this example. And look, equation got shifted on me again. So please rewrite this. Why is this all separate? It's all good. It's y equals negative 3/4 x plus 4. So if you need to rewrite that, go for it. Oh, you know what? One more thing I want to mention up here about opposite reciprocal slopes. Write this off to the side. If you have a slope that's like, let's say your slope is 2. How do you get an opposite reciprocal slope of 2? Well, you have to flip it. Well, if there's no bottom, remember, just like slope when we graph, we put a 1 under it. Now we can flip it. So if your slope is 2, then you put a 2 over 1, and then you flip it. So when you flip it, you're going to make it 1/2, and then don't forget to make it opposite. If it was 2, now it's negative 1/2. So negative 1/2 and 2 are perpendicular slopes. Okay? So put a 1 under it and flip it. Same thing. What if you have a slope of, let's say, 1/2? If you have a slope of 1/2, okay, if you have a slope of 1/2, to find the opposite reciprocal, you would flip it and get 2 over 1, which 2 over 1 is just 2, and then you would have to make it opposite. So 1/2 and negative 2 are opposite reciprocals. Okay? All right. My daughter's home. You can probably hear her. All right, so example 2. Sorry, my daughter just got home from school and she's like excited to see my dog. All right, so here we go. What is the equation of the line in slope-intercept form? So it's the same type of question as above, but it says that the point, it's got to pass through the point 3, negative 5, and it has to be perpendicular to y equals negative 3/4 x plus 4. So it has to be perpendicular this time. So we're going to do the same thing, except we can't use the same slope. We have to use a perpendicular slope, which if I look back up here, perpendicular slopes have to be opposite reciprocals. So what that means is we're going to take the opposite of a negative, and my slope is going to be positive. And we have to take the reciprocal, which means take 3/4 and flip it to 4/3. Okay, so we're going to go ahead and use the slope of 4/3 so we know it's perpendicular to this equation. And we have to find our new b. So y equals, we know, is going to be 4/3 x, but the new b is what we're going to find, just like we found it up here. We found a new b up here, we're going to find a new b down here. All right, and we do it the same way. We use y equals mx plus b, and we plug in our numbers. We plug in our y, which is right over here. Y is negative 5. M, our slope that we have to use that's perpendicular, is 4/3 times x, which is 3, and then plus b, because that's what we're going to solve for. So we can go ahead and multiply 4/3 times 3, and when you multiply that together, use your calculator if you need to, you get 4 plus b equals negative 5. And then from there, you're going to subtract 4 from both sides of the equation to solve for b. So b in this case, which is our y-intercept, would equal negative 9. All right, so we don't need that plus there. We're going to cross that out and just write minus 9 for negative 9. So there is our equation that's perpendicular to this one, okay? Because look, it's got a 4/3 slope, which is flipped, and this one is negative, and this one is positive. You have to have an opposite reciprocal slope. Okay, so why don't you guys pause? To help you really quick, I just want to make sure you understand with a perpendicular slope, you want this to be the opposite reciprocal, so you might need to put a 1 under it in order to find the opposite reciprocal slope. Okay, go ahead and pause, give it a try, and when you're ready, come back. All right, you should be back. Here we go. Hopefully you did well. The first thing we're going to do is figure out what our perpendicular slope is. So in order for me to find that out, I know it's opposite. So if this one's positive, mine has to be negative. And then I have to do the reciprocal. So 1/2. So I can start to write my equation. Y equals negative 1/2 x, because that's my perpendicular slope. And now I need to find my new b. Okay, I can't just use this one. I got to find the one that goes through this point. If I just use this one, it's not going to go through this point. Okay, so I have to use the point in order for it to go through the point. So here we go. We got y, which is 7, equals m, which is negative 1/2, times x, which is 4, plus b. All right. From here, we're going to do negative 1/2 times 4. So do that in your calculator if you need to. That's negative 2 plus b equals 7. Add the 2 to the other side of the equation to solve for b. And you get b equals 9. Looks great. So we're going to put the 9 at the end of our equation, and there is our answer. This line, negative 1/2 x plus 9, is going to be perpendicular to this equation. Okay, so it's going to form 90-degree angles, and it will go through the point 4, 7. Okay, if you want me to go back to that calculator, I'll show you. So y equals 2x plus 4 was my original equation. So y equals, okay, let me go with 2x plus 4. The ordered pair that it needs to go through is 4, 7. Oops, I guess I need this, huh? 4, 7, so let me change these. This is 7. And this one is 4. Okay, so there's the point. Okay, we can see what we got. So here's my first line, here's the point, and the equation that we just wrote is y equals, and it was negative 1/2 x plus 9. So here we go, negative 1/2 x plus 9. Okay, watch, guys. See what happens. Oh, look at that. Pretty. All right, so look, we got a 90-degree angle right here. So this will be our 90-degree angle. And look, that new line goes right through that point because we used it. Okay, so it's kind of cool to be able to see it on the graph. That's why I'm pulling it up and showing you. Okay. All right, let's move on. The last two, we are not going to do this story problem. It's a little excessive. We'll talk about some story problems later, but this one's a little much. So we're not going to do 4, but we are going to do 3. So to finish this up, we need to be able to classify lines, which means just tell if they're parallel, if they're perpendicular, or if they're not either one. Okay, so if they're neither. So what we need to do, how do you know if you have parallel lines? Right, you look at their slopes, and if they're the same, they're parallel. So what if they're perpendicular? Right, they have to be opposite reciprocals. And what if they're neither? Then they're neither, right? So that makes sense. They might be something different. Okay, so if I'm looking at this first slope, letter A, I want to know if this line is parallel to this line or perpendicular or neither. So looking at this equation, I can see that the first slope is negative 3/4. In the second equation, I can't see what the slope is. Remember, because you have to solve it for y. The only way you can see the slope is if it's solved for y, and that second equation is not. So we want to take a quick second, solve it for y, and I can see 4 divided by 3 is 4/3, 6 divided by 3 is 2. I can see the slope here is 4/3. So is it parallel? Are they the same? Nope. Is it perpendicular? Well, this one's negative, this one's positive, so they're opposites. Are they reciprocals? Are they flipped? They sure are. So we can say that these two equations are going to make perpendicular lines. Okay, so that's all you have to do. For the second one, same thing. We're going to look at the slopes. This one is solved for y, so we can see that the slope is 2. This one is also solved for y, so I can see my slope is 1/2. All right, so let's check them out. Are they parallel? Meaning, are they the same? Nope. Are they perpendicular? Well, perpendicular, I have to have one positive and one negative. Nope, that's not negative. So this is neither. Because they don't have the same slope, so they're not parallel, and they don't have opposite slopes, so they can't be perpendicular because they have to be opposite and reciprocal. They are reciprocals, but they're not opposites. Okay, and then the last one, here we go. So you got y equals negative 5x. So that one is in slope-intercept form because y is by itself. So your slope is negative 5. And this one we got to solve. This is nowhere near slope-intercept form. So minus 25x. So sometimes it's a little bit of extra work, but it's not too much. If we learned how to solve for y correctly, this should just take a second. So remember, do not combine these. Go ahead and divide by 5. So y equals negative 25 divided by 5 is negative 5x plus 1/5. Well, that's not nice. But that's cool because it doesn't matter. What do we need to look at? The slope. And I see the slope is negative 5, which is the same as this slope. So these lines are parallel. Okay, so that's how we do parallel and perpendicular lines. We are able to tell whether they're parallel perpendicular or neither by finding their slopes, which means you have to solve for y first if it's not, and then compare using the rules above. So remember, you might, when you're doing your work on this, you might need to look back at these rules and look at these examples that we've done together to help you. But this is the same concept that we learned when we were finding the b. In order for us to write an equation in slope-intercept form in section 2.1. Okay, so I have office hours. Let me know if you guys have any questions or need any help. All right, we will talk to you soon.